You ever look at a car with a tiny little engine and wonder, how in the world does it have so much power? Well, today we're pulling back the curtain on the magic trick that makes it all happen. We're talking about the turbocharger.
So let's start with a basic engineering problem, right? It's a puzzle that designers have been trying to solve for, more than 100 years now. How do you make an engine more powerful?
For a long time, the answer was just brute force. You want more power? Build a bigger engine. Simple. But that means more fuel, a ton more weight. It's not exactly an elegant solution, you know? But then a much cleverer idea came along: forced induction. The whole concept is, instead of making the engine bigger, what if you could just get more air into the one you already have?
Okay, so here's what we're going to cover today. We'll start with why a smaller engine can make more power, then get into exactly how a turbo works. After that, we'll talk about the big problem with turbos and the smart ways engineers fixed it. And we'll wrap up with what you should look out for if you think your turbo might be failing.
So at its heart, an engine is just a big air pump that creates explosions. And the power it makes, that's all about the size of those explosions. A bigger bang means more power. And to get a bigger bang, you need two things: more fuel and more air. But here's the thing, you can't just dump more fuel in. It's like a recipe. You need the right mix of ingredients. Without enough air, that extra fuel just won't burn right.
And you know, this idea, it's not some newfangled tech. It was actually patented way back in 1905 by a Swiss engineer named Alfred Bucchi. It's pretty wild. Its first job was for airplanes, helping their engines breathe in the thin air at high altitudes. From there, it moved into big trucks, and then finally into the cars that you and I drive every day.
So here's the key takeaway. What a turbo really does is it lets a small engine punch way above its weight class. It's like a magic trick. It compresses air, stuffs it into the engine, and suddenly that little engine thinks it's a big V8. You get more power, sometimes a lot more, like 20, 30, even 40% more, all from the same size engine.
Okay, so that's the what. Now for the how. How does this thing actually work? It's actually a really ingenious recycling system.
So the simplest way to picture a turbo is to think of two little pinwheels, or fans, stuck on either end of a single shaft. But these aren't your garden variety pinwheels. They spin at absolutely insane speeds. We're talking over 150,000 RPM. That's just mind-bogglingly fast. One of these pinwheels is called the turbine, and the other is the compressor.
All right, now this is the truly brilliant part. You know all that hot exhaust gas that normally just gets spewed out your tailpipe? Total waste, right? Well, a turbo captures that waste energy. It channels that hot gas to spin one of the pinwheels, the turbine. So think about that. The turbo is literally powered by energy that your engine was just throwing away. It's basically a free power boost.
And since that turbine is connected by a shaft to the other pinwheel, a compressor, when one spins, the other has to spin too. So the hot exhaust spins the turbine, which spins the compressor, and the compressor's job is to act like a super powerful vacuum cleaner. It sucks in fresh air from the outside, compresses it, squeezing it down, and then shoves that super dense, oxygen-packed air right into the engine. And what happens when you have more oxygen? You get a much bigger, more powerful bang.
So let's just walk through that one more time. The engine makes hot exhaust. That exhaust spins the turbine. The turbine spins the compressor. The compressor crams fresh, dense air into the engine. And more air means you can burn more fuel, which equals, you guessed it, more power. It's this beautiful, self-contained loop that turns waste into horsepower.
But it wasn't perfect. For a long time, this amazing piece of engineering had a really famous, really annoying flaw. A problem that every driver could feel, and it was the turbo's biggest Achilles heel for decades.
I'm sure you've heard the term before, turbo lag, and this is it. It's that moment when you put your foot down on the gas pedal and nothing happens. Just for a second. There's this delay, this hesitation, and then whoosh, the power kicks in. It's super frustrating.
So why does that happen? Well, think about it. To get that turbine spinning really fast, you need a lot of exhaust gas pushing on it. But when your engine is just idling or at low RPMs, it's barely puffing out any exhaust. It's not enough to get that turbine wheel moving quickly. So there's a delay while the engine builds up revs, pushes out more exhaust, and gets the turbo to spool up. That wait is what we call lag.
Now you know engineers, they can't stand an unsolved problem. They couldn't just let turbo lag be a thing. So naturally, they came up with some incredibly clever ways to fix it, to make turbos faster and way more responsive.
So there are two main ways to tame a turbo. First, you've got the wastegate.
This is basically a safety valve. Its only job is to make sure the turbo doesn't get carried away and create too much pressure, which could damage the engine. If things get too spicy, the wastegate opens up and bleeds off the extra pressure. Simple. But then you have something much, much smarter. The variable geometry turbo, or VGT. This is a real game changer. Imagine putting a nozzle on a garden hose. The VGT does something similar with the exhaust gas. At low speeds, it makes the opening smaller, which makes the gas flow faster, just like putting your thumb over the hose. This faster gas spins the turbine up much quicker, basically eliminating lag. Then at high speeds, it opens up fully. It's not just for safety, it's all about performance.
Okay, let's switch gears and talk about the real world. What happens when things go wrong? You're driving along and suddenly you lose power, or there's a weird whining sound, or you see smoke coming out the back. The first thought is often, oh no, my turbo's toast. This is going to cost a fortune. But a lot of the time, it's not what you think.
Now, there are definitely some classic signs of a real turbo failure. A loud, high-pitched whining noise that sounds kind of like a dentist's drill or a siren, that's a bad sign. Seeing blue or black smoke out of the exhaust, also not good. A major loss of power, or your car suddenly using a lot of oil? Yeah, those could all point to the turbo itself.
But, and this is a really big but, before you panic, you need to know that a bunch of much simpler and much cheaper problems can look exactly the same. That loss of power, it could just be a tiny crack in a $5 hose. That smoke, maybe it's just a clogged up valve. Your check engine light comes on and the car has no power. It could just be a bad sensor telling the computer the wrong thing.
So the key takeaway here is simple. Don't automatically assume the worst. So many times what looks like a catastrophic turbo failure is actually a simple fix on a part that supports the turbo. Getting it diagnosed properly is absolutely critical. It can literally save you thousands of dollars.
When you step back and look at it, the turbocharger is just an incredible piece of engineering. It's a testament to human ingenuity, literally turning wasted energy into raw power. It gave the good old combustion engine a whole new lease on life. And that kind of makes you wonder, right? As we start moving into this new electric era, what's going to be the next big innovation that gives us a free boost?